All right, diving right in today, we're looking at the World Economic Forum's top 10 emerging technologies of 2024.
Over 300 experts contributed to this, so we're dealing with some serious brain power here.
A hyper-concentrated dose of knowledge about, what could actually change the world. Ready to get into it.
Absolutely, yeah. We've got some really fascinating stuff here. AI revolutionizing scientific discovery, harnessing microbes for climate change, the whole works.
Okay, well, let's start with something that I think impacts everybody, connectivity. We're creating more data than ever before, and it feels like sometimes our current infrastructure is struggling to keep up. I'm
Yeah.
sure I'm not the only one who deals with internet slowdowns, right?
No, definitely not. But good news, some very cool solutions are coming up. One that caught my eye was reconfigurable intelligent surfaces, or RIS for short.
RIS. Okay, so break that down for me.
Basically, picture this. What if the surfaces around your walls, ceilings, even furniture could act like smart antennas, always adapting to optimize wireless signals?
Instead of needing a router in every room, the whole house becomes a giant antenna.
Exactly. But it goes way beyond your home Wi-Fi. Think about smart factories, where machines need to talk to each other seamlessly, or even rural areas lacking traditional internet infrastructure.
Yeah.
RIS could really bridge that digital divide.
Now that's using tech to solve real-world problems. And speaking of reaching those remote areas, what about places where it's just not feasible to build traditional infrastructure?
That's where high-altitude platform stations, HAPS, step in. Picture balloons or airships 20 kilometers up, beaming the internet down to even the most remote spots.
Internet from the sky. That sounds like something straight out of science fiction.
It does, but it's being tested right now. Think about the impact connecting those 2.6 billion people still offline. It could revolutionize education, healthcare, even economic development. Plus, they can be deployed quickly in emergencies, providing vital communication.
Like a mobile network in the stratosphere. That's pretty impressive. But we're not done with connectivity yet, are we?
Not quite. There's also integrated sensing and communication, or ISAC, which aims to combine sensing and communication functions into one super efficient system.
So instead of separate systems for monitoring things like air quality and transmitting data, ISAC could handle it all.
Precisely. Imagine sensors built into city infrastructure, constantly monitoring air quality, traffic, energy use, and using that data in real time to optimize everything. We're talking about smart, responsive environments.
All right, let's shift gears a bit and talk about AI. I mean, it's everywhere these days, but how is it actually changing the game for scientific discovery?
Well, it's moving beyond just crunching numbers.
Yeah.
It's helping us discover new knowledge. One great example is AlphaFold, an AI developed by DeepMind. It can predict the 3D structures of proteins, something that used to take years of research.
So instead of years in a lab, scientists can just ask the AI for the structure.
Well, it's not quite that simple, but it's definitely sped things up, especially in fields like drug discovery.
Now that's what I call a breakthrough. So what other areas are we seeing AI impact?
Identifying new antibiotics, creating better batteries, even designing new materials. The potential for personalized medicine and clean energy is enormous.
That's incredible. But with all this talk about AI and data, I have to ask about privacy concerns. Is there a way to allow for scientific collaboration without putting sensitive data at risk?
That's where synthetic data comes in. It's a way to create realistic but anonymous data sets, mimicking real data patterns without containing any actual personal information.
So like a standing for the real deal.
Exactly. It allows global collaboration without sharing sensitive data, which opens up a ton of possibilities for medical research and beyond.
It sounds like we're on the cusp of a scientific renaissance. But let's turn to an issue that's on everybody's minds, climate change. Are any of these technologies offering solutions there?
Absolutely. There are some really promising advances. One that caught my eye is elasticalorics.
Elasticalorics. Okay, you got to break that one down for me.
It's all about materials that heat up when you stretch them and cool down when they're released.
You're telling me we could cool our homes by stretching something?
Sounds wild, but it's a real area of research with huge potential. Think about replacing those power-hungry, environmentally unfriendly AC units with elasticaloric heat pumps.
Now that would be a game changer. Any other innovative approaches on the horizon?
Believe it or not, tiny organisms, microbial carbon capture is a big one.
Microbes fighting climate change? How does that even work?
There are a couple of ways, actually. One is using algae and bacteria that naturally absorb CO2 during photosynthesis. We can use this to capture CO2 from the air or industrial emissions.
Letting nature do the work for us.
Exactly. Another way is using microbes to convert that captured CO2 into useful stuff like biofuels. You're reducing greenhouse gases and creating renewable energy at the same time.
Talk about turning trash into treasure. Speaking of sustainability, what about the environmental impact of our food, especially animal agriculture?
That's another area where these emerging technologies are making a difference. Alternative livestock feeds are becoming more popular as a more sustainable way to get protein to animals.
So what are we talking about here? Like some kind of futuristic protein shake for cows?
Well, not a shake exactly, but researchers are looking at protein from single-cell organisms, algae, and even food waste. All of these have a much smaller environmental footprint than traditional soy-based feeds.
So instead of deforestation for soy, we're turning waste into resources. That's a circular economy in action.
It really is, and it shows how these technologies are all connected, working together to tackle multiple challenges.
Okay, we've covered some pretty mind-blowing stuff in connectivity, scientific discovery, and climate action. But there's one more I'm super excited to discuss: genomics and the future of organ transplants.
This is where we're seeing truly remarkable progress. The need for organs far outweighs the supply, but genomics is opening up new doors.
I'm all ears.
Advances in gene editing, especially CRISPR, are letting scientists engineer organs. In fact, the first successful transplant of a genetically engineered organ has already happened.
That is a huge step forward. It gives so much hope to people waiting for transplants.
It does, and it's just the beginning. We might be on the edge of a whole new era in medicine where genomics can solve the organ shortage and transform healthcare as we know it.
Wow, I'm already blown away, and we've only covered half the list.
I know it's a lot, but we're just getting started. In part 2, we'll dive into the rest, including wearable robotics, spatial omics, and much more.
All right, we're back and ready for round 2, diving into the second half of the World Economic Forum's top 10 emerging technologies of 2024.
We've seen how tech is changing connectivity, scientific discovery, making things more sustainable. Now let's see how it's boosting human capabilities and revolutionizing healthcare.
Okay, let's hear it. What's up first?
Let's talk about wearable robotics. It's moving beyond those big, bulky exoskeletons we've seen. Think lightweight, intuitive devices, almost like a second skin.
So less Iron Man, more like a supportive layer.
Yeah, exactly. Imagine flexible exosuits that help with physically demanding jobs. Less strain, fewer injuries for workers in construction, manufacturing, healthcare even.
That would be huge for so many people, and I imagine it could really improve accessibility, too.
Absolutely. Wearable robotics could help people with disabilities regain mobility, give them more freedom to move and interact with the world.
So we've gone from boosting our connections to boosting our physical abilities. What's next?
We're going deep inside the human body with spatial omics. This field is changing how we understand biology at the cellular level.
Spatial omics? That sounds pretty intense. What exactly are we talking about here?
Imagine a high-resolution 3D map of our cells. But it's more than just a picture. It combines imaging with genomic sequencing. So you see not just where cells are, but what genes they're expressing and how they're interacting.
So it's like Google Maps for our cells, but with way more detail.
That's a great analogy. And that detail is crucial for disease research, developing new drugs, and personalized medicine. Imagine pinpointing the exact location of a disease at the cellular level, or seeing how individual cells react to treatments.
That's incredible. It sounds like we're on the verge of a whole new era of healthcare. But with all this tech, I can't help but think, what about the environmental cost of our digital footprint?
That's a really important consideration. As we rely more on digital tech, data centers and all our devices use more energy. That's why sustainable computing is becoming so critical.
So we're talking about making our digital world more energy efficient.
Right, exactly.
Yeah.
It's about more efficient servers and data centers, but it goes further than that. Researchers are looking at totally different ways of computing, like neuromorphic computing, which is inspired by how efficient the human brain is.
So instead of traditional computer chips, we could have computers that work more like our brains.
That's the idea. Neuromorphic computing could drastically cut energy use and open up new possibilities for AI that's more adaptable and intuitive.
It's amazing how we're turning to nature for inspiration to make tech more sustainable. What else is there?
Now, let's talk about a technology that's blending biology and electronics, flexible neural electronics.
Okay, that seems futuristic and a little bit scary. What exactly is that?
Imagine electronics so thin and flexible they can merge with the human nervous system. Implantable devices that can monitor and interact with the brain and nerves in ways we've never seen before.
So we're going from wearables that track our steps to ones that could potentially track brain activity.
That's one application. But think about the possibilities for treating neurological disorders like Parkinson's, epilepsy, spinal cord injuries. Imagine delivering targeted therapies directly to the affected areas of the nervous system.
It's like having a direct line to the control center of the body. Pretty incredible. So what's the last one on our list?
Well, we've got a game changer for healthcare research and development, patient-centric clinical trials.
I've heard of clinical trials, but what makes them patient-centric?
Traditional trials are often these huge studies with thousands of people. Patient-centric trials are more focused on smaller, personalized approaches. It's about tailoring treatments to each individual patient.
So recognizing that everyone's different and needs a unique approach.
All right. These trials use wearable sensors, telemedicine, even AI to gather real-world data and personalized treatment plans.
This sounds like a big step towards truly personalized medicine.
It is. And it could make clinical trials more efficient, effective, and available to a lot more people.
We've covered a lot of ground here, haven't we? Looking at these top 10 emerging technologies from the World Economic Forum, from those reconfigurable surfaces for connectivity to genomics and organ transplants, it feels like we're in a whole new era of tech.
Yeah, it's amazing to see how fast things are moving and the range of these new technologies. We're tackling global problems, pushing science further, redefining healthcare. It's a lot.
Definitely a lot to process. As we wrap up, I'm curious what stands out to you most from this whole report.
For me, it's how interconnected these technologies are. It's not just individual advancements, like they're all pieces of a bigger picture come together, like how AI is being used in so many different areas, or the shift towards personalized healthcare with those patient-centric trials.
That's a great point. It's not just the tech itself, it's how it all fits together. But it makes me wonder, what about the downsides? Are there risks we need to consider with all this progress?
Oh, absolutely. These technologies have huge potential. We need to be realistic. Any powerful tool can have unintended consequences.
Like what kinds of consequences?
Well, take AI, for example.
Right.
As we become more reliant on it, we have to make sure it's developed responsibly. What about jobs, privacy, even fairness across society? Those are big questions.
Well, it's not just the technology, it's the social and ethical side of things, too.
Exactly. We need to make sure these advancements are good for everyone, that we're building a future that's not just technologically advanced, but fair and sustainable.
That makes a lot of sense. It sounds like the challenge is finding that balance, embracing the potential, but being aware of the risks.
I think that's spot on, and it needs everyone to be involved, researchers, policymakers, industry leaders, even the public. We all need to talk about this, work together, and stick to ethical principles.
It really feels like we all have a part to play in shaping where tech takes us.
We do. And it all starts with being informed. The more we understand these technologies, the good and the bad, the better we can make smart choices for the future.
So to everyone listening out there, I encourage you keep learning about this stuff. Ask questions, share your thoughts. The future of technology isn't set in stone. We're all building it together.
Well said. As we wrap up, I'll leave you with this. These technologies show us what's possible, but it's up to us to decide what kind of future we want.
That's a great point to end on. Thank you for joining us for this deep dive into the World Economic Forum's Top 10 Emerging Technologies of 2024. We hope you found it informative, got you thinking, and maybe even left you feeling inspired. Until next time, keep exploring, keep asking questions, and keep imagining what's possible.